Hello, welcome to Fire Engineering Training Minutes. I'm Jason DeFosse from Trenton, Ontario, Canada, and this is Dalan Zartman from Columbus, Ohio. Today we're talking about the BMW EV. Also in this segment, we're going to be talking about shutdown procedures as well as thermal assessment. Dalan?
This is best performed by two individuals. One individual provides technical support while the other individual attacks the initial shutdown procedures. We want to make sure that we don't delay clearing the vehicle of victims and performing those critical first steps to gain access.
All right, after the vehicle has been properly stabilized through aggressive wheel chocking efforts as well as shoring operations, we now want to gain access into the passenger compartment by trying the door and opening it. Locate the hood latch, and then this one is a mechanical latch which requires two pulls. At this location, we want to ensure that the dash has gone black and the parking brake is engaged. From here, we come around to the front, lift open the hood, and as per the ERG, our emergency response guidelines, we can locate our first responder cut loop, which is right here. As a first responder, we want to take that tag and remove it and give that to our rescue captain. While we're in this position here, we're actually going to remove this cosmetic panel, exposing some of the high voltage components. Unlike other EVs on the market, this is not identified as a trunk or a storage space, but actually houses one of the other drive motors as well as some high voltage components. We're going to review that now. So just in identification of our high voltage components, anytime we have warning stickers such as this with lightning bolts, as well as the bright orange high voltage cables coming in and out of these systems, these are areas of best practice to avoid during your rescue assignments. In the event we can't locate our first responder cut loop at the front of the vehicle, as per the ERG, we have a second option here in the rear. We're going to try or breach the rear deck lid. And in here, on the rear passenger side under the cosmetic panel, is a two-stage relay. We're going to disconnect it now.
When performing technical support for an EV operation, we've identified that the vehicle is in fact an EV through logos and badging. We then want to identify make, model, and year. Utilizing mobile applications or the NFPA access portal, we bring up the ERG that correlates to this vehicle. There's key things that we're focused on here. One of them is being identification of the components, the priority being all the high voltage systems. So we want to make sure that we identify where the high voltage battery pack is, as well as the high voltage cabling. Secondary focus is any low voltage interaction that interrupts or isolates high voltage energy. On our grids, that is always indicated by a yellow symbol surrounded by an orange border. So the orange represents high voltage, the yellow represents low voltage. If the orange border is around the yellow symbol, again, that's low voltage interaction that impacts high voltage energy. The first responder cut loop would be identified as a yellow symbol with orange border, as well as a secondary relay. We'll call out those components to the operator that's performing shutdown procedures. That allows him to efficiently work through the vehicle. While the operator is performing shutdown procedures, we want to make sure that we're providing safety support, identifying the potential for thermal event. That's best accomplished through the use of gas meters and thermal imaging cameras. When we navigate away from the emergency response guide, our thermal imaging cameras should be utilized to identify inconsistent hot spots within the battery pack. You'll never have a uniform heating of the battery pack in a thermal event. The temperature indicator within the thermal imaging camera is used as a trending tool. So any temperatures increasing, it would be indications of a potential thermal event. The other important factor is odor. Lithium-ion batteries emit an odor that smells like an electric light ballast or any type of electrical motor burning with a sweet, fruity odor to it. If that is coupled with any indications of hot spot, increasing temperatures, that would be an indication of thermal event. The last confirmation tool that we use to verify a thermal event is gas meters. That can be accomplished through a CO detector or through a 4 or 5 gas meter. It's important that coming off of the rig, you establish a baseline for your CO. Your fire apparatus will be producing CO. Once you have that baseline established and you approach the vehicle, any values of increasing CO will be further confirmation of a potential thermal event. If the potential for a thermal event is confirmed through any one of these mechanisms, all firefighters should remove themselves from the area, ensure that they have full SCBA protection on, and advance lines to prepare for fire suppression operations to further the rescue sequence.
In this video, we've gone over best practices on how to interact with this specific EV. We've gone through shutdown procedures as well as thermal assessments and the proper tools to do the job. Dalan?
Yeah, remember the importance of tech support. We need to reference our emergency response guides to find those components that are critical to the operation, and then use your instruments that are available to you as firefighters to identify potential thermal events. Most important takeaway is to make sure that you protect yourselves, don full SCBA and PPE in the presence of a thermal event, and make sure that we prioritize victim identification, access, and removal from the vehicle.
Thanks for watching Fire Engineering's Training Minutes.